This is the prerequisite worksheet for section 3.6, graphs of rational functions. We have 3 objectives in this worksheet. We will begin with number 1, domain and range in interval notation. This is not new, but a nice review. So for our domain, we're looking for all of the x values that are in the domain of this function. So as you can see this arrow, we have all of these x values until we come to x equal to 4 and also include 4. So that would be negative infinity going all the way to 4, including 4, since it's a closed point. Now, taking a look at the range, we start down here, and we don't see anything until we hit x equal to 3, and then we will go all the way to infinity because of that negative. So let's go ahead and take this off. So as you can see, our range will be from negative 3 all the way to infinity. And I can go ahead and draw our domain, which was from negative infinity all the way to a 4. Sometimes it's nice to draw that on the graph. Now, we don't have any arrows on the endpoints here, so this domain is going to be from negative 5 all the way to a positive 3. And our range, as you can see, is from a negative 3 all the way to a positive 2. Okay, so domain and range from a graph is not too bad. What we're going to do now is look at the domain only of these rational functions other than number 3, which is a polynomial function. 2 things we need to make sure that we remember. We are going to factor if needed. Factor the denominator if needed first. Okay, now this is a polynomial, and the domain of all polynomial functions is negative infinity to infinity, all real numbers. Now looking at number 4, we're going to be able to write g of x as 1 divided by x minus 4 multiplied by x plus 1. Now, as you can see, x cannot be equal to 4 or a negative 1. So we have to remove those from the domain. So our domain is going to be from negative infinity to negative 1, negative 1 to a positive 4, and union with a positive 4 to infinity. So pretty important that we remove those restricted values in order to write that domain. Okay, looking at number 5, as you can see, we can reduce that to x minus 4 divided by x minus 4 multiplied by x minus 1. Now, what they asked us to do was just to write the domain. They did not ask us to simplify. So again, we have this, that should be a positive 1. So what do they want us to know? Even though we could simplify and write this like this, keep in mind for the restricted values that doesn't change. So x cannot be equal to 4 and negative 1 again, and we have this same domain that we had in the previous problem. So what is the point that they are trying to say? Even though this can be simplified, we still must include that domain before, find that domain before we simplify. Okay, and we do know that that can be simplified. Okay, let's go ahead and take a look at number 6. And in number 6, as you can see, x plus 9, if we set that equal to 0, so x equal to negative 9 is a restricted value. Just like here, these are restricted values. Okay, so our domain cannot include negative 9. So we have negative infinity to negative 9, union negative 9 to infinity. So basically, this is just the number line, and negative 9 is not included. So there are our two intervals, negative infinity to negative 9, and negative 9 to positive infinity. That's what that looks like. Okay, let's take a look at number 7. Here we can write p of x as 2x divided by x plus 3 multiplied by x minus 3. As you can see, x equal to 3 and negative 3 are restricted values. So our domain is going to be negative infinity to negative 3, union with negative 3 to 3, and then union with 3 to infinity. So we cannot include those restricted values in the domain. Now, I can't show you here that if you set x squared plus 9 equal to 0, and you get x squared equals negative 9, and x equals plus or minus, and then you get plus or minus 3i, that is not real. So here, as you can see, there are no restricted real numbers. So the real numbers, that domain is going to be negative infinity to infinity. Okay. Now we are actually going to be solving rational equations, finding the real solutions to these equations. And remember, the domain is going to be the real numbers. Okay, so looking at number 9, we want to find the real solutions to this equation. So what we're going to do is when we set 2x minus 1 equal to 0, we multiply both sides by x squared minus 2x minus 3. What we will do is multiply both sides by x squared minus 2x minus 3. Maybe I'll write that on the next line. So our problem is 2x minus 1 divided by x squared minus 2x minus 3 equal to 0. And the concept here is to help students understand that we only care about the numerator when we are solving equations. So these cancel, and we end up with 2x minus 1 equals 0. And then we will add 1 to both sides and divide both sides by 2. So here we have x equal to 1/2. Now we do have to make sure we don't have a restricted value. So this denominator is x minus 3, x plus 1. So x equal to 3 and x equal to -1 are restricted values. In other words, they cannot be solutions, and we're okay. This is not a restricted value. Okay? Looking at number 10, again, the concept is just to set the numerator equal to 0 to solve. But 2 cannot equal to 0. Therefore, there is no solution to number 10. Okay, looking at number 11, what we have here is we will multiply. Let's get this written down a little bit better. And we will multiply both sides by that denominator. And here you can see that those cancel, and we get 2x squared minus 1 equals 2x squared minus 4x minus 6. So setting this equal to 0, I'll go ahead and write this out. We're going to subtract 2x squared from both sides, and you can see that we get -1 equals -4x minus 6. Now we will add 6 to both sides, and we have 5 equals -4x. We will divide both sides by a -4, and we get x is equal to -5/4. Now we do want to check to see if we have a restricted value. So we will go and look at this denominator, and again it's x minus 3. Is that the same one we had there? So x minus 3 multiplied by x plus 1, and x equal to 3 and -1 are restricted values. And we are okay. This is not a restricted value. This is in the domain. Okay, now we are going to have a little practice dividing polynomials. Here we can't use synthetic division. We have to use we do have to use long division on number 13. But let's go ahead and take a look at number 12, because we can use synthetic division. Okay, so 5 goes in the box, and we have 2, -9, and -9. Here we will drop the 2, and -4 is the remainder. So what is this equal to? We can say that in number 12, we can actually make this statement, 2x squared minus 9x minus 9 divided by x minus 5 is equal to, now read this line, this is 2x plus 1 is equal to 2x plus 1 minus 4 over x minus 5. Because x minus 5 is the divisor. So that is actually the division problem that we would be working on. And I will just bring that right on down here, and I'll just change this little arrow to that, okay? Okay, now we have some long division ahead of us, and we will go ahead and write this as x squared minus 5. And then, just like we used to do long time ago, we have 2x cubed minus 3x squared minus 9x plus 11. Okay, so we are looking at this 2x cubed and this x squared in order to decide what we are going to have. And yes, that would be a 2x. So we have a 2x cubed minus 10x. Here we will subtract, and we end up with a negative 3x squared, and this is a negative 9 plus a 10. So a negative 9 plus 10, and we will have a positive 1x, and we will go ahead and bring that 11 down. Now we will have a negative 3, and we have a negative 3x squared minus 15, subtracting again, and we end up with x, and we have 11 minus a minus, so 11 plus 15, and that will be 26. Okay, so I think that's what that is. Let me see. I think this was supposed to be a positive 15, so a negative 3x squared plus 15. So that would give us an 11 minus 15, so that's a negative 4. That looks better. So this is our remainder. So we could say that in number 13, we could say that 2x cubed minus 3x squared minus 9x plus 11, all divided by x squared minus 5 is equal to, let's see what we can do here. Why don't I just erase that? Is equal to 2x minus 3 plus x minus 4 over x squared minus 5. And that concludes this worksheet.